Okay, the last type of reciprocal function of a quadratic is the one that's corresponding to the reciprocal of this parabola. A parabola is lifted above the x-axis. So for example, y equals x squared plus 2. Okay. Note that this function is completely positive. All the y values on this parabola is positive. If you want to draw the reciprocal of that, okay, how would it look? That the function is decreasing up to here. Okay, it's going down, and from here, when x is greater than 0, so when x is less than 0, the function is decreasing. When x is positive, it's increasing. This means the reciprocal function, okay, so 1 over x squared plus 2 will be increasing in the same interval. 1 over that will be decreasing. So it'll be increasing and decreasing. Now do you see we have a minimum value there, a minimum value of 2? For the reciprocal, okay, for the reciprocal, we'll have a maximum value that's reciprocal of that, which is 1 over 2. So if this was 2, here's 1, that will be our maximum. So let's zoom in a bit here. And we have this still as our horizontal asymptote. So the graph needs to decrease because it's increasing. It needs to decrease towards that and decrease towards that. That is our reciprocal function. Okay, that looks so flat. Maybe let's do another one. I'll just do 5 over x squared plus maybe here plus 1. So the parabola of y equals x squared plus 1, here's 1, and it's going to go up from there. 1, 2, 3, 4, 5. Okay, so it's decreasing, increasing, so it's going to increase and decrease. This one has a minimum value at 1. So the reciprocal function will have a maximum of 1 over 1, the reciprocal of that, but we still have to times it by 5. Okay, so if there was no 5, the maximum will be 1. Okay, so the graph actually will look like just like this. It'll go up and come back down. But because of that 5, we'll go all the way to the top there, and that will be our max. Okay, so the graph, we still have this as our horizontal. It will look like the following. And despite how my picture looks, it's perfectly a mirror image on the y-axis. So x equals 0 is the axis of symmetry. Okay, let's do one more where we can make this upside down. Okay, so a good way to think about this is to bring that negative below. Okay, so that is minus x squared minus 2. That looks like the following. Okay, so it's a parabola that looks like this. Okay, if you take the reciprocal of negative 2, it's negative half, but we're going to times it by 2. So we get negative 1. So this has a maximum, right? This is a max. The reciprocal, that will be a minimum. And this is still our horizontal asymptote because when this gets large, overall the whole thing is approaching 0. Okay, so we're going to approach this. And this is a minimum, right? So it's got to do this. Again, despite how my picture looks, this is a symmetric graph on the y-axis. All right. Maybe, okay, you know what? Let me do one more. Let's sketch the following. Okay, so let's say 2x minus 1 squared plus 2. Okay, so this one at the bottom here, it's a parabola. The vertex located at 1 and 2. And it goes up from there. So it has a minimum, and when x equals 1, it has a minimum of 2. So the reciprocal have a maximum at half, so half there, but that needs to be multiplied by that 2. So if that was 1, that would be our point, but we gotta double it. From there, it's increasing, so we gotta decrease towards the x-axis. It's decreasing, so we gotta increase towards our maximum value. All right, so hopefully you get a solid sense how to draw the reciprocal of a rational function where the parabola at the bottom is not touching the x-axis.